All right. Phew. Oh. Are we ready? Are we ready to go? Yeah, okay, thank you. Well, hello everyone. My name is Michel Trudeau. I work at Oracle in the Java language team. I'd like to talk to you today about what we're working on in our area, some language features and tooling features. So first, I'd like to talk about some language enhancements and tooling that we are responsible for, and we've been doing in the last 6 months releases since JDK 10. Each of the releases contains a little bit of features, but cumulatively, it becomes more and more interesting. But first, I'd like to do a poll just to find out in the room who's using JDK 8. Okay, most people. Who's using JDK 11? Oh, that's pretty good, okay. And JDK 12? Okay, well, a little bit more people. Okay, that's good. So most people are on JDK 8, and quite a few of you are on JDK 11. And the nice thing is, from 9 on, it becomes increasingly easier to migrate from one release to another, as there are fewer changes and there are a lot more control over what's going in, and there are less breaking changes, essentially. Some of the features that I talked about were mentioned in the keynotes. I'm going to go into a bit more detail, and so a little bit of advertisement here. If you want to use JDK, the latest JDK, it's available at that website. Today we're announcing JDK 13. It's available to be downloaded, and if you want to download any other builds, early access builds, or special feature builds such as Loom, OpenJFX, Panama, etc., you could download them from that website. They're not production build. Only JDK 13 here is the production build. Starting with language enhancements, I'll focus more on the language feature available today, and I'm going to also touch base on some of the language on our roadmap, language features on our roadmap. Starting with the first feature, in JDK 10 we introduced local variable type inference. So that's enhancing the Java language to extend type inference to declarations of local variables with initializers. The goal here is to improve developer experience by reducing some code ceremony associated with declarations. Looking at these examples here, as you could see, the type can be inferred from the right-hand side by the initializer. And therefore, repeating the same type on the left-hand side becomes noisy, let's say. var shouldn't be used for every cases, but there are cases where it's very useful and it's perfectly fine. And also, var is available for formal parameter of implicitly typed lambda expression. So reading is more important. Reading code is more important than writing code, and therefore var must be properly used. We provide a style guideline and a FAQ at those links to describe extensively how var should be used. And there was a presentation, or there is a presentation as well at Oracle Code One from Stuart Marks, who goes very deep in the details of var. So, but I'd like to talk about some of the most important guidelines, 3 of them essentially. So the first one, it's about choosing a variable name that provides useful information. In general, it's a good practice, but in the context of var, it's even more important. In the variable name, we can encode a lot of information. So as an example below, a database connection, when we execute a query, it returns a result. And this result we could assign it to a variable name that's very descriptive, such as customer list, or we could use some X, Y, Z, which are not very descriptive. As you could see, when you use something meaningful like customer list, saying using var is very convenient. It's not very descriptive to say, oh, it's of type list of customers. Same thing for other kind of results that could be returned by a database connection, such as customers, instead of just calling this result, as I often see in JDBC or other database application. A second guideline here is to consider var when the initializer provides sufficient information to the reader. Local variables are often initialized with a constructor or a factory method call. Here, as a first example, you have a local variable, an output stream, which is initialized with a call to a constructor called byte array output stream. Repeating the same type on the left-hand side becomes noisy. var is very convenient here, and output stream is clear enough to be used throughout the method without having to refer most of the time to what the type of that variable was. Same thing for factory method calls, such as new buffered reader and list of. Using var makes it very convenient, clear, and also for those who like the aesthetics of typing code, it helps you align your list of local variables. A third one, it's got to do with complex lambda expressions. Here I've got a complex expression, which is not really complex. It's only 4 lines, but my slides are not very big. But it's often the case that lambda expression could be 10 lines and sometimes even more. And therefore, breaking them sometimes make things a little bit more clear. But when you break them, you're going to realize quickly to try to figure out the return type of your partial lambda expression might be complex. So using var in that case is very convenient. So here is an example where I've got a list of blocks, and some of them are blue, and I want to find the one with the heaviest of the blue blocks. So first I could simplify my pipeline by extracting first the blue blocks, and then figuring out the maximum weight of these blue blocks. And I don't have to worry about what is the type returned by that filter method there, using var. Next language feature I'd like to talk about is actually a preview language feature in JDK 13. So before talking about this next feature, I'd like to introduce a concept of previews. So we have introduced this in JDK 11. So a preview language or VM feature is a new feature of the Java SE platform that is fully specified, fully implemented, but not permanent. And to use a preview feature, you need to use the --enable -preview flag, command line argument on the tools. Or if you're using an IDE, NetBeans, IntelliJ, and these other IDEs are providing very good support for preview features by now. The other upside for us of providing a preview feature is that it helps us with the faster release cadence of 6 months. So 6 months comes very, very quickly, and it helps providing a feature as a preview first so that in the real world, if we didn't get it completely right, we have a chance to fix it. And by introducing the first preview feature, switch expression, it's a case in point here. We've introduced first in 12. And then after real-world example, we realized that the feature was not yet quite perfect. So we made one more change, and we reintroduced it in JDK 13 as a preview feature again. So the switch expression, it's extending the switch statement so that it can be used as either a statement or an expression, and that both forms can use a traditional or simplified scoping and control flow behavior. These changes will simplify everyday coding. So the goal here is to fix several irregularities of the existing switch statement, which includes the default control flow behavior fall through of switch blocks, the default scoping of switch blocks, and the fact that switch is available only as a statement. In Java, the switch statement is modeled after C and C++, which is very old, and it's got fall through semantics by default. And while this was quite powerful and very convenient to write very low-level code, in higher-level application, it's more error-prone in nature, and its flexible, super flexible benefit starts to outweigh its flexibility here. So we're fixing this. And to talk about it, I'm going to go through some examples and the feature of the switch expression. So here's an example here where many switch statements are essentially simulations of switch expressions. So here, each arm assigns to a common variable, and then this variable is used after the switch statement to perform some additional operation. Here's a nicer way to write the same code. And with this little snippet of code, I'm actually presenting all the features of this new switch expression. So first, there's a new form for the case statement with an arrow instead of a column. Second, with this new form, there are no more breaks needed. Third, you could specify one or more labels on each case statement. Like the first case statement, we have three labels. Before, we had to say case Monday column, case Friday column, etc. And you could use the switch statement as an expression. On the right-hand side of this arrow, you can only have the following type of statement: an expression, a block statement, or a throw exception. So the switch expression raises additional requirements since every case arm must compute a value of compatible type or throw an exception. So the code here that I'm showing is safer as there's no chance to forget a break and there's no chance of falling through. So the target type, a switch expression is a poly expression. If the target type is known, this type is pushed down into each arm and type check is enforced. The type of a switch expression is its target type, if known. If not, a standalone type is computing by combining the types of each case arm. In that case, the target type is not known. We're using var. Therefore, we need to look at the type of each case statement. And the type of each case statement in that example is fairly simple. Therefore, for integers. If one of them would be something not compatible with an integer, an error would be raised by the compiler. And all the standard coercion conversion type applies here. About yielding a value. So most switch expression will have a single expression to the right case, to the right side of the arrow. In the event that a full block is needed, we're using yield with an argument which becomes the value of the enclosing switch expression. So in that case, in the default case, it's a little bit more complex than just like a simple expression. We have a block, but we need to return a value to the switch expression from that block. We do this using the yield statement. So a switch expression can, like a switch statement, also use the traditional switch block with case statements, the old case statement type with the column and the break and all that. In this case, values would be yielded using the yield with value statement. But we don't believe people will resort to this old form of case statement to write switch expression. But it's available. It's part of the language. Another aspect of switch expression is the case of a switch expression must be exhaustive. For any possible value, there must be a matching switch label. This means that by default, a default clause is required, except for the case of an enum switch expression that covers all known case. In the first example, we're switching on an integer. So therefore, it's most likely impossible to specify all the integer values here. So therefore, there needs to be a default case. If not, if there's no default statement, it's an error. The second one, we're using only 2 of the enumeration from the days of the week. So therefore, we also need a default case. Furthermore, a switch expression must complete normally with a value or throw an exception. This has a number of consequences. The compiler checks that for every switch label, if it is matched, then a value can be yielded. Here's some example where in case Monday, I have a block and I'm doing some processing in my block, but I'm not returning anything. That's a compiler error. Same thing in the second example in the default case where I'm not returning anything from my switch expression. So in summary, here are some of the advantages of the switch expression feature. It provides exhaustive coverage of case statements. It improved the scoping rules and less needs for temporary locals. There's no fall through on the right-hand side of the case statement. And there's a choice of using an expression or a block statement on the right-hand side. So another preview feature we have in JDK 13 are text blocks. So a text box is a multi-line string, a literal that avoids the need for most escape sequences, automatically formats the string in a predictive way, and gives the developer control over format if desired. This new JEP replaced raw string literal, which we talked about in previous Oracle Code 1. Raw string literal has been withdrawn. So here's an example of how a multi-line string was done in Java previously. I've got this little HTML snippet of code, properly indented, but still a small snippet of code where, and then on the right-hand side, I got the same literal, but using multi-line strings, text blocks. So by passing it between a pair of triple double quotes, the code is equivalent on the left side, and it's more readable and much easier to code. There's no need to add a \n on each line to surround this by single double quotes on each, and to add the plus sign, the concatenation operator. And the result is the same. It's a string literal. So it's a great way to insert snippet of code or text in the source code while preserving indentation. So I mentioned formatting and indentation. We are providing some additional method in the string library to perform additional processing on text blocks, but by default, there are some built-in formatting, a minimal built-in formatting. So moving to a multi-line format, it left us with a dilemma. We want to indent the text block along with our code, but we probably don't want the incidental indentation to show up in the string. We use the position of the closing delimiter to determine which indentation is essential and which one is accidental, and we trim off the accidental indentation. In this example below, all the gray dots indicate which indentation was deemed accidental and will be removed as part of it. So this was a little bit complicated to explain, but I'd like to do just a little demo just to show you how this accidental versus essential indentation works here. Hopefully that's going to work. All right, that works. Okay, so I got a JShell session here, and I've got a simple multi-line string that I'm printing. So if I print that multi-line string, as you could see, all the extra white space at the beginning has been removed, but the indentation has been preserved. So to calculate this, it's essentially we take the line in the multi-line string that is the leftmost margin. In that case, body/body and the ending triple quotes are all aligned. But for example, since I mentioned that the closing delimiter was important in calculating that incidental space, if I just space this one in just by one character, the result is that I have a one space in the beginning of every single line in my multi-line string. If I bring my closing delimiter all the way to the beginning, whoops. Okay, I made a mistake here, so. All right, sorry about that. That should be simpler. Then here, as you could see, all the left margin space becomes significant, becomes part of the string. All right, going back. Good. So next, I'd like to talk a little bit about the features that are on our roadmap that is coming in the near term, hopefully. So the first feature is records. So records provide a compact syntax for declaring classes that are nothing more or mostly plain data carriers that serves as simple aggregates. I've got an example of a record right there. It's a point, and it's containing two components, X and Y. And therefore, this is a full record declaration. But the records acquires many standard members automatically. So there's some code generated as part of those records here. And some of the code generated is there's a private final field for each component. There's a public read accessor for each component, and a public constructor, and an implementation of equals hashcode and toString. So on the next slide, I'm going to show what all this generated code looks like, essentially. So we have a constructor, we have an implementation of equals, hashcode, and toString, and we have our two public accessors for our X and Y. And these X and Y are immutable. They cannot be changed. The next feature I'd like to introduce is seal types. So they are classes or interfaces that impose restrictions on which other classes or interfaces may extend or implement them. As an example here, I've got a node, which is a seal type. And with the implicit permits clause here, it specifies that node may be extended only by the types enumerated by that clause, which is A, B, and C. And furthermore, these members must be in the same module, or if node is in the unnamed module, in the same package. So sealing serves two distinct purposes. It restricts which classes may be a subclass of a seal class, and it also potentially enables exhaustiveness analysis at the use site, such as when switching over type patterns for an instance of a seal type. It's currently no longer available. It's currently not available to switch on a type pattern, but this is another feature that we are working on. Introducing the next feature, pattern matching. This is the first release of this pattern matching list of features. And what we are doing here is enhancing the enhance operator here to remove the need for a cast. So essentially, in the first example, this is standard Java code where I test that object is an instance of a string. And then if it is, then in my if statement, the first thing I need to do to use object as a string, I need to cast it to a string. So this new form that we're introducing is we're doing a test and a binding at the same time. So if object is an instance of a string, we're binding it to the variable name mentioned, which is S in that case. Therefore, if that test is true, in the if statement, you don't need to cast anymore, and you could start using S. So therefore, it reduces the number of casts you have in your application, makes your code shorter, makes your code safer, and simpler to read. Some of the tooling enhancements that we've been working on as well since JDK 10 is, one of them is launching a single file source code program. So introduced in JDK 11, it's enhancing the Java launcher to run a program supplied as a single file of Java source code, including usage from within a script by means of shebang files and related techniques. So the motivation why we did this is to help learn Java, and it's also to write small utility programs, and it's also to provide a way to run directly from source, reducing some overhead of compiling and packaging. So we are essentially adding a fourth mode of running an entry point in Java. The first mode being you could run a class. The second one, you could run a jar that contains a main class. The third one is a module. And the fourth one is a source file directly. So the source file that you may want to run may have an extension or no extension at all. If it has got an extension, I assume it's going to be .java, but it could be something else if you really wanted to. So here's an example of running something without an extension, hello world. And dash source can be used to specify the source version of the source code. So here's an example how to run a single file source code with you could specify the dash source, and then you could specify dash enable preview, and my source file that I want to run is testing switch expression, which is a preview feature. Therefore, I need the enable preview flag. Source file is compiled to memory and executed. Therefore, there are no .class saved. And this is a little bit under the hood what's happening. Java, it's calling under the hood Java C, and it's generating the class file to memory, and then it's reading that class file from memory. And arguments can be specified to the source file. They're passed directly to the running class. Here, arg1 and arg2 are passed to hello world. So shebang files on Unix-based system, there's a feature called shebang file. This feature can be used to write small utility programs, and therefore now in Java. It is desirable to be able to run a program directly from source, and shebang provides a mechanism for this, and it's available on Unix-based systems such as macOS and Linux. It's a mechanism provided by the operating system which allowed a single file program, whether it's in Python, in Perl, or in Java, to be placed in any conveniently named executable file whose first line begins with !! and which specifies the name of program to execute. So here's an example of a shebang file. We call it hello world. And the first line starts with a ! and an ! And then the location of the Java launcher we want to run this application with, and with some additional command line argument to pass to the Java launcher if needed. And to execute this hello world, if you want to execute it by itself, you set the executable bit on the file, and then you can run it. Some additional things we've been doing in the tooling areas, we've been doing some Javadoc improvements over the last few releases. So first, we have a Javadoc search now. Second, we are HTML5 by default. We still support HTML4 with the -- HTML4 flag, but it's HTML5 by default. We've done over the last several releases several module improvements to better support the module system. We've also added features to manage broken links better. We have a cleaner, simpler navigation bar. There's no more previous, next, all classes, frames, and no frames, since it's a no-frame application now. And we're constantly improving accessibility. The Javadoc documentation itself for the platform is almost perfectly accessible free now. And we provide a new Doclet API, much better supported and documented Doclet API and implementation. Eventually, the old Doclet API and implementation will be removed. And occasionally, we deprecate feature and we remove feature as well. So in JDK 10, we remove Java H. The same feature is available through the Java C command line. You just need to use the -h command line argument. And in JDK 11, we deprecated two features, the Nashorn JavaScript engine and the PAC200 tools and its API. These features are still available. You can still use them in 12, still use them in 13, but we're still having a plan to remove them soon when we're going to find a stable replacement for them. As well, before we remove these features, we will have to submit a new JEP, and we will have to socialize this JEP with the community that we are removing this feature. So it's not going to happen out of the dark. There's a process for this. So using the new features, like I mentioned, you could download the latest build, and as part of downloading the latest build on this JDK JavaNet page, we have release notes, we have the API Javadoc for this new feature, and we have builds for Linux, Mac, and Windows 64-bit. It's easy for a release or a build to find the list of new features through the list of JEPs, but new releases of Java implements dozens, if not hundreds, of new enhancements as well that are not JEP. There are smaller enhancements, but that doesn't mean they're not very useful. And most of these enhancements that are worth noting and documenting are part of the release notes. The release notes are fairly large. They are well categorized. Inside the release notes, you're going to have a section for new feature, a section for incompatible changes, and some other section as well. But the section for new feature is very, very useful. I'm mentioning this because I know many people don't read the release notes, but they're very useful. And we spend a lot of time doing them. And then you could use your favorite IDE. Nowadays, IntelliJ and NetBeans are becoming more and more, support more and more EA releases quickly. And you could subscribe to the mailing list to stay informed. So beyond JDK 13, throughout the conference, you might have heard about these project names. And our team, the language and tooling team, is involved with some of these projects, Amber, Valhalla, and Panama being some of them. Project Amber, so essentially this is the goal of Project Amber is to explore and incubate smaller productivity-oriented Java language feature. I showed some of them that are available today. I showed some of them that are our near-term roadmap, and we have many more on our long-term roadmap. Project Valhalla is to introduce value types to the platform, and Project Panama is to improve the interconnection of the JVM and native code. And I'm going to talk a little bit about Project Panama because my team is also spending a fair amount of time on that project, and that project is becoming more and more ready. So the philosophy behind Panama is to make it much easier to consume native libraries by making them look like ordinary Java interfaces. And to provide tools to make accessing native memory safer, to generate code dynamically rather than statically, eliminating brittle, error-prone artifacts, and to make it easy to package native library with tools which library developers can use to extract Java bindings from native APIs. So the status of the project, it works. It's been tested on real-world libraries such as TensorFlow, BLAS, and other machine learning-based library. So one thing about Project Panama, it's a little bit the replacement for JNI. And essentially why we're doing this, well, a good part of why we're doing this is we recognize the fact that there are some extensive amount of native library out there that are doing some very, very useful stuff, especially in the machine learning / artificial intelligence space. So the Panama feature is big, like many other projects we're working in the JDK. And as we've mentioned in the keynote and some other presentation, we need to deliver these features in stages, in much smaller pieces. And the first deliverable for Project Panama that we're working on is the memory access API. So a little bit more about this memory access. It's an off-heap memory access built on top of existing var-handle machinery. It's to be the replacement of the byte buffer and the replacement of unsafe. And the performance is very, very good right now. And we have a JEP, and we are pushing the JEP through the right channels in order to socialize the API and hopefully move this to a near future release. The next step in this architecture is the foreign function layer, so the ability to call native methods, and it's built on top of method handled. And the third step is the tooling support for it through a tool called JExtract. And through a tool called JExtract, you could read C header files or C++, but right now C works really well, like standard I/O, and it will generate Java interfaces that you'll be able to access the C methods directly through it. And the code to make the transition from Java to C is generated dynamically through the binder on the fly. So the goal of this layered architecture is to minimize risk and is to deliver incrementally these features. So again, You can download a little bit more advertisement here. You could download those bills from this simple website. It's a very simple website. There's not a whole lot on that website, but it contains all the essential to download the bills for the current release and for the early access bill for future releases and project bills as well. That concludes my presentation. Thank you. Thank you. Questions? Oh, okay.
Can you potentially talk more about value types?
Yes, I can talk a little bit more about value types. I don't have any slides because there's been many some other presentation about it, but value types is currently, I'm going to keep it simple here. So let's assume you have a collection, an array list of objects. And the array list of objects is essentially a set of references to these objects. So therefore, it uses additional memory to point to all sorts of locations to have references to those objects. The goal of turning a collection of objects from a references to value types is to have an array list of data types directly, instead of having an array list of references to those data types. So this is a simple case. We have some demos, actually. There was a demo in the keynote that essentially converted it was a Mandelbrot demo, and it converted some main data structure inside the Mandelbrot demo from reference to inline types. And the result was running the applications was 3 times faster, just by reducing the overhead of allocating all those references and also improving the memory locality of that data.
So it's really about kind of keeping essentially multiple objects joined together in memory, so to say, and without the overhead of object headers and whatnot. So it's really relevant when you have collections of objects or arrays.
It's really useful with arrays and collections. That's what it's meant for. Yes, that's where the real performance is going to come from. Yeah. The reason why I'm not expanding too much on Valhalla is because my team is currently not the biggest focus of my team, because there's a lot of VM work that is happening right now. And once we ship the VM work, we'll be able to ship the language feature built on top of it and the library support for it as well. Any other question? Can you use the microphone for other people? The microphone is right up there. No, if you could use the microphone, thank you. Yeah, yeah. Oh, it should work. Oh, it doesn't work? Oh, okay. Where's my audio guy? He left. Okay, so go ahead. I'm sorry.
Okay, about switch statement.
Yeah.
The new approach is applicable only when you are going to return a value.
Mm-hmm.
Why don't you consider a possibility to make it void? For example, if I want to execute in each case just some command not returning.
Okay, so the question is why, in a switch statement, we need to return a value. And then why couldn't we consider making it void, making some of those case statement voids? Well, the reason where we need to return a value is in the case of a switch expression, not a switch statement. A switch statement does not return a value. It's the switch expression part that returns a value.
In case of statement, can I apply the new format?
In the case of statement, you could use the new format of the case statement. Yes, it looks really nice as well. I just don't display all the possible cases here for the... Pardon me? Yeah, just embrace it. Yeah, yeah. So it's really nice. Yes. Mm-hmm.
So you can still write a switch actually statement, but in a more compact format.
Yes, I would. Yeah, I would have liked to keep a slide for this. Yeah. Oh, yes, you can. Yes, and we believe that the new form is going to be used by 99% of the people. The old form, you really only need it when you need to break through, to fall through a case. At this point.
Why you exclude Nashorn? It's not.
Yeah, why did we deprecate Nashorn? Well, there are better alternatives out there, and GraalVM is working on Truffle.js, is a much better alternative to Nashorn. Therefore, from an investment purpose for the JDK community, what they need to invest on, what they need to prioritize on, we had to make some choices, and JavaScript 6 was a huge undertaking. So therefore, we didn't want to put all this investment in both Nashorn and Truffle.js. So we decided to focus Truffle.js focus on keeping JavaScript up to date, and Truffle.js will soon, hopefully, be a product, and therefore it will be the replacement for Nashorn in the JDK. And the goal as well, when we're going to remove Nashorn, Truffle.js will be a module that's going to be available. You just need to download it, and you just need to reference it, and it's fine. It's much simpler. With the module system, we no longer need to ship everything with the JDK. Other question? Well, thank you. Thank you, everyone. Yes.
Question not related to this one. So I'm using REST Assure for writing my functional test automation. So can I use Java docs in integrating with it?
Well, that's a good question. I'm not
I see a
sure.
lot of things
But
like for unit test cases,
yeah,
Java docs like
yeah.
can it use for functional test cases?
Oh, yes, yes, yes. Functional tests. Yes, yes. Yeah, definitely.
So it prepares the test plan like using the Java docs. So
Yes, you
currently
could.
we are
Yes.
writing the test plan manually.
Oh,
So it's
yeah,
not
that would be
like-
really nice. Yeah, yeah, yeah. So definitely you could do that. Yes.
Okay. But you are not sure about the REST assured integration with.
No, that I'm not sure about. Yes, we have a Java doc mailing list. You could definitely ask on the mailing
So
list.
what is
And
the mailing
javadoc-java.net. Let me check. Let me just give me a moment here. Yeah.
OpenJDK.
Okay, yes. I think it's java.dev. It is java.dev.
So java.dev at openjdk.java.net. Yeah. Sure. Yeah. To the point. I'm trying to make it to the point. And I had 5 times more people than Bernard.
Who's at the back?
I was counting. Oh, hello. How are you? Yes, hello. Yes. We've seen each other a lot during the conference.
I was forgot to ask Brian Goods when do you expect a date for the live tonight? I wouldn't ask him.
There's no dates. There's no dates.
Could be 2 years,
give that.
could be 3.
I don't. We don't. With this new release cadence, we don't.
I got this question all the time.
I know, and we're not that we're going out of our way not to specify a date, but we don't want to make any promises.
Yeah, of course.
Yeah. What is the date?
6 months after he's done.
Oh, okay. Yeah. Okay. Yeah. Thank you. Thank you.
After the workload
No,
function, yes,
really-
you mentioned it, yeah.
Really, we cannot
But
make any
okay.
promises
But
anymore.
We need to
so.
turn this into something actionable. So when people, I recognize your name now,
Yeah.
hello, you do good stuff, don't you?
I'm just going to grab my.
When someone asks that, we have to take this as an opportunity to find out something from them. What could that be? Because people are just parroting us at this point. No one has that.
Yeah.
They just know that it's something about performance. So if you say if they consume a few of these source codes, it's going to get faster. That too.
They always claim the stuff was Kotlin. Well, yeah.
Even with the fast.
That's
These are live. Okay, good. It's fine, I guess. Let's see who shows up at this hour. Hopefully, kind of late. Sure. Oh. Clicker.
You have your own clicker.
Yeah.
Okay.
Yeah. I just. Oh wow, that was loud. That's okay. Yeah, that works.
It's easier to turn you down than to turn you up.
Yeah.
So
Yeah.
it's at that.
Okay. No, that's okay. I mean, I will probably won't be sitting down, so that distance sounds to me like it picks me up, so that's okay, I guess.
Yeah, I would say that if you're going to walk away from this area, then probably the clip-on would be a good idea. But if you're basically just kind of standing and sitting, then you're fine with that.
Yeah, I'll be standing here. That's okay. Really? Oh, where you just, is Eric's talk in parallel? No.
But it's actually some talking about it right now.
I think there was something in parallel. And I couldn't come to your talk this morning because in parallel there were like 2 other things.
There is no, at the moment nothing is parallel, but it's already evening, so it's not the best time.
It's not the best slot anyway.
Yeah, it's not the best slot. It's like so much content.
Yes. Also, I'm guessing that some people really only go to one GraalVM talk in the entire time, so the first 10 minutes is always repeating, like, what is it?
Random. So one of the Oracle guys apparently got free Oracle people first time.
Oh, wow.
Everyone else who turned up was an Oracle person. Oracle.
Okay, starting, I guess. So, hi. Let's get started to this. I guess this is the last set of sessions of the day, right? Thanks for showing up still. I'm Tim Felgentreff. I am part of the GraalVM Python team in Oracle Labs. But this talk isn't going to be about Python. It's going to be about how especially the native image capabilities of GraalVM enable you to do cross-platform development on top of GraalVM. And I'm just going to talk about how that enables that and how it's faster also on different platforms. A couple of you have probably already seen this slide, but just in case you haven't, GraalVM team is a big team. I'm just one person in that team. While I tried to make everything in these slides truthful and to the best of my knowledge, I might have made mistakes or plans may change, so please don't take these slides as a plan to productize anything in particular. Is that out of the way? GraalVM. So there's different ways to look at cross-platform development on GraalVM. And this is one of the pictures that we always use to kind of explain what GraalVM is to different people. Because it kind of shows the different orthogonal points of view that you can take when you're talking about cross-platform on Graal. Because GraalVM already is a platform, right, that allows you to run allows you to run different languages on top of it. Obviously, the JVM languages, Java, Kotlin, Scala, what have you. But also dynamic languages. Right now, we officially have JavaScript and experimental languages like Ruby, R, and Python. But GraalVM also allows you to run statically compiled languages like C, C++, and Rust that compile to LLVM bitcode. And for all of these, GraalVM is the platform. So all of these, so everything I'm going to say here in this talk pretty much applies to all of these languages that run on top of GraalVM. Then GraalVM itself runs on different platforms. The common thing that people thought about and that like kind of where historically GraalVM started is running on top of Hotspot, either an OpenAI JDK or an Oracle JDK. And thus, it's cross-platform in the sense that the JVM is cross-platform. And in this configuration, if you're running on OpenJDK, basically what you're getting is kind of the same thing as if you were running on top of Hotspot with those capabilities, just with GraalVM and the Graal compiler as the just-in-time compiler and these capabilities to run different languages in a high-performance manner. However, the GraalVM also comes with a feature called native image. And that allows us to embed it into different other platforms. One prominent one that is already included in GraalVM right now is on top of the Node.js platform, which is basically a huge bunch of C++ code, right? And you're embedding some JavaScript runtime into that huge bunch of C++ code. GraalVM also runs inside the database, the Oracle database, or MySQL, for example. And with GraalVM native image, you can also compile anything, any Java application, and any of these dynamic language interpreters or the LLVM bitcode interpreter into a standalone binary. The technology that enables all of these things, really at the core, is the Graal compiler. This is really where the project started, if you will. The Graal compiler started as a research project to write a just-in-time compiler, a production just-in-time compiler in Java, so in a higher level language than is common for just-in-time compilers, really. Usually these are written in C or C++, kind of system languages, if you will. It being written in Java had the advantage that we could make it more modular and more easily extensible and maintainable than especially older just-in-time compilers that have been grown over the years and that had kind of outgrown their potential to be extended, including just-in-time compilers for hotspot. GraalVM and the compiler inside comes in two different flavors, the Community Edition and the Enterprise Edition. I'm not going to get into it too much in this talk, just so much here in the context of the Graal compiler. The Community Edition has fewer of these modular optimizations that we're able to plug into the compiler. Enterprise gives you more optimizations. That's just in the context of the compiler. There's other advantages to Enterprise that aren't relevant to this talk. And some of the advanced optimizations that are in the Graal compiler that are relevant for the performance that GraalVM gives you are partial escape analysis, where we understand that some objects, for example, never escape from a certain code path, so they don't actually need to be allocated, for example. Path duplication, where we try to specialize code path by duplicating them for your specific workloads, and inlining, very, very sophisticated inlining strategies. And what that allows us to do is easily deal with high-level language concepts, for example, in Java. Like here, where you have this streaming API usage, and where traditionally we had to work, or a lot of work had to be done on a just-in-time compiler to make the above code just as fast as if you had spelled it out in this lower level kind of way. And the Graal compiler, on the Graal compiler, really this on top here really turns into the same machine code as the one here at the bottom. There's really no difference. The Graal compiler sees through all of this abstraction and makes the code go as fast as possible, really. Because these kind of high-level concepts are poorly expressed in more traditional, older sets of JVM benchmarks, we have partnered as the labs with, among others, Charles University in Prague to make this, create a new benchmark suite that is more, that really shows more modern workloads on the JVM. This new benchmark suite is called Renaissance. And it has a few different modern workloads, including the usage of these high-level APIs, like the streaming APIs. There's benchmarks in there that use Scala as an example of a different language on top of the JVM that that, for example, the hotspot JIT compiler had to have a lot of work done to support more efficiently. And here what you can see in this benchmark is there's like all these separate benchmarks, and here at the end, that's what you want to look at, is the geomean speed up over C2 for GraalVM Enterprise Edition and Community Edition. And really what you want to take away from this is that on average for these kind of modern workloads, if you're running Enterprise Edition, you're going to be about 30% faster. And even if you're just using Community Edition, you're already going to be 6 to 7% faster for these modern workloads on average. That's the kind of speed up you can expect. And if you're more interested not only in these high-level APIs, but in different JVM languages like Scala, we can look at Scala bench also, and here the Graal compiler really shines, and you can see higher geomean speedups here, up to almost 40% for Enterprise Edition, and these speedups are one of the reasons why Twitter has been using GraalVM and running some of the services on GraalVM for a while, and that also kind of goes to show that it's already quite a stable. It's stable. It's a stable, very stable compiler that you can use that's production ready. Now, it being written, the Graal compiler being written in Java, if you tried it maybe a couple of years back, you may have noticed slower warm-up times compared to the C2 compiler, because the Graal compiler itself being written in Java first had to warm up itself, and then had to be warmed up itself, and then it could warm up your application. And before we get into native image proper, I just wanted to show that we've completely fixed this problem with what we call libgraal, where we use GraalVM native image to produce a shared object of the compiler itself. So it's kind of this meta-circular thing where you're using the compiler, compile itself into a native object, and use that native object to as the just-in-time compiler, for example, on hotspot here. And with libgraal, instead of the Java version of the Graal compiler, you can see that you're warming up extremely fast, and you're really on par with C2, and then you're overpassing it for peak performance. So there's really no reason then to not use the Graal compiler and GraalVM instead of hotspot. And not only is this important for your server workloads where you care about peak performance, it's also important for workloads that take less time and that you're starting over and over again. Like if you're compiling, for example, as a developer on your development machine. Here are some numbers comparing just running the Scala compiler on different projects, normally on OpenJDK, Java 8, on GraalVM Enterprise Edition, and then using Bloop, which is an alternative Scala compilation tool set where you pipeline the compilations, both again on Java and on GraalVM, well, on JDK and on GraalVM. And in each of these cases, you can see that GraalVM, because it warms up quickly now and it reaches high peak performance, actually finishes the workload faster than it would if you're running the compiler without GraalVM. So this is about developer productivity, right? This is not only about using fewer servers to run the same stuff or less CPU time. This is also, think about hundreds of developers waiting an additional couple of seconds every time they're compiling something. And this is also one of the advantages that Graal gives you. So if you're not using GraalVM yet, there's really no reason not to at least give the Community Edition a try, because it just probably gives you a 7% performance boost right from the bat. And you can also try the Enterprise Edition for evaluation and see kind of where you're going to get likely around 30% speed up. So really don't waste the time and also not the energy, the resources. Think about the climate and use GraalVM. Now, I alluded to native image for the Graal compiler for itself, and native image is at the core of this cross-platform story that we have for GraalVM. And just as a very, very kind of abstract overview of what native image does, the goal of native image, GraalVM native image, is to give you fast startup, small footprint with the same nice high peak performance that GraalVM on OpenJDK gives you. And how that works is it takes all of your Java code, so your application code, all the libraries that you're using, the JDK standard library, and some libraries in what we call substrate VM, and analyzes your program in what we call a closed world assumption. And what we're doing is we're basically looking at your program from the entry points and starting to check, oh, so which classes are you using? Okay, I'm going to load these classes and check their static initializers. And then I'm going to see what classes these classes depend on, and then load those classes. And we iterate this process, pulling in all of the classes that your application actually needs, but none of the classes that it doesn't use. So you're not pulling in all of the Java standard library, you're not pulling in all of the classes that are in the libraries that you're using. You're really tree shaking your dependencies, and you're really ending up with a tiny binary that really encapsulates only what you need. And there, all the classes are already loaded and basically frozen into this binary. And the way we do this is, the way we freeze it into the binary is, once we've figured out all the classes and all the methods that you need, we AOT compile those Java methods, and we initialize those classes, or we start initializing those classes, and we take a snapshot of that heap and save it into a binary. And so what you end up with is a binary that has some machine code for all your Java code, and that has a snapshot of the already beginning to load application of yours. And this is where the fast startup comes from. Yes?
Sorry, what does AOT mean?
Ahead of time, I'm sorry. Yes, I should have mentioned, ahead of time compiled. So what that means is when you start up your GraalVM native application, one of the reasons you're faster is because some of the work has already been done at compile time, right? You have already initialized some of your classes. You've loaded all of those classes already. You don't need to hit like the rt.jar again to figure out which classes you need and all that stuff. This is just kind of a really, really high level, small example again. If you have like a Hello World Scala program, you run it on the JVM. This is the kind of startup you get, and if you push this through native image, you get a native binary that doesn't have a dependency on like normal JVM on your system, and you immediately get like an order of magnitude speed up. And this is for a tiny application where you really, when you're starting the application on the JVM, you're really not spending that much time loading classes. It's just a hello world. So the order of magnitude improvement that you can expect for startup with native image in a large application is much larger. And you can see this if you went to any of the Leiden or Quarkus talks. You can see this if you look at microservices where they're using native image, and they're kind of really pushing native image also for their own products to start up much, much faster, because you're not going through all this meta stuff to figure out which classes you need and load them. And the same is true for these services in terms of memory footprint. You're easily cutting your memory footprint by a factor of 5 or more. Now, before I talked about just-in-time compilation, and now I talked a little bit about kind of mentioned AOT compilation. These two things are separate, but they go together, obviously. You could have a native image where you're just running the AOT compiled code. You could have a native image where you have the AOT compiled code and just-in-time compiler inside also, and combinations thereof. If you have both, yes, go ahead.
Sorry, you might have just about to cover it. Does that allow you to add additional classes?
No.
To the class spec?
No, it doesn't allow you to add additional classes, because we have this closed world assumption, and only if you have this closed world assumption can you actually get down to these small binary sizes, right? Because if you don't have that, then you're basically just pulling in all of the JDK libraries again, and what are you going to win, really? Yeah. So what I was going to say is, if you have a native binary and you still have a JIT compiler inside of it, obviously there's still going to be some warm-up difference. It starts up fast, and there's already kind of optimized code in there, AOT compiled code, but as it profiles your application, the just-in-time compiler might re-optimize some of these methods that you have inside your binary. You can improve that warm-up once again if you go through a multi-stage process and use profile-guided optimizations, which we support with native image, where you create one binary that's instrumented, and then you run some of your workloads, it will notice what kind of optimizations it should be doing, and then it will create a new binary with more optimized code and further cutting down on startup time. You can iterate these. So you can create more profiles, and then the native image can incorporate these profiles. And here, just as a kind of warm-up curve, rough idea. So with native image, you're fast from the start. You're really not warming up very much anymore. And on JDK, obviously, you need some time to warm up the code and everything until you reach kind of the same performance. This drop here at the end, kind of an artifact of this measurement, and technically there are still like a few cases where we're slightly smaller with native image, but we're working on that, and it's really nothing that's super concerning, really. One of the things that is noticeable sometimes, especially with longer running applications still right now with native image, is that the GC that we have when you create a native binary from GraalVM is not as good as the one that comes on the JVM, as some of the GCs that come with the JVM. But we're working on that also. We're creating a new GC that's going to be better and much faster and more suited to high memory workloads also. The other part where native image really shines, again, is the developer productivity. If you have command line tools, these need to start fast, warm up fast, and finish fast. And here again, if you have a profile-guided, optimized native image tool, and then you run these command line tools, you're just gonna be much faster. Even for tools that start up fast and then run for a longer time, like Scala C. So Scala C is one of these tools where, like, it takes a long time usually to start it up on the JVM, and then it may continue running actually for quite a long time, where the JVM eventually will also warm up. And even there, if you're on Enterprise Edition, you still beat anything you could run on the JVM through the fastest startup and then the peak performance. So the native image and the tooling around it is ready for wide adoption, and we've seen lots of people use it already. We sorted out most of the unsupported features. It's very well documented what is unsupported and how to work around these things. For example, reflection and additional, like, dealing with resources and all of these kind of things that are more dynamic can be dealt with native image. And so really we are encouraging people to try the frameworks, to use it with their applications, and if there are any issues, report them. We are very active on GitHub and really try to really engage with the community there. Now, all of this, what I talked about, was kind of for these server workloads and desktop machines, developer machines, so kind of x86, 64. But we are also adding other backends to the native image to target other platforms, like mobile platforms or kind of store apps that are restricted in some sense or another. One of the ways we're doing this is supporting LLVM as a backend for native image. So rather than creating a machine code binary, we create an LLVM bitcode file, a binary with LLVM bitcode inside, and this has multiple advantages. One of the advantages, obviously, is that now this thing will run or can be targeted to any platform that LLVM supports. So if you have some niche platform, but LLVM supports it, this will allow you to take your Java application, or really any application in one of the languages that runs on top of GraalVM, and turn it into a binary that runs on any of these niche platforms that LLVM supports. The other advantage is that in case, for example, Apple starts requiring LLVM bitcode when you submit apps to the App Store, we got you covered also, because we're not just creating a binary that's kind of a black box. We actually create bitcode, and then you can submit that, and then they will use that. So this is not, so the current state shouldn't be taken as, oh, this is the entire story. It's really an outward-looking story where you can increasingly be sure that if you're creating an application that can be turned into a native image with GraalVM, it will be easy to port it to different platforms because of these backends that we're supporting. At this time, the LLVM backend is still very new, and using it comes at a price. The GC that we have for LLVM is even more experimental than the GC we currently have in native image anyway. But as I said, we're working on GC for native image in any case. So this will be fixed sooner rather than later. The other thing is that, and the other two things are really kind of derived from the same thing, but it might not be obvious, so we put them separately here. The runtime generated code is slightly slower if you're outputting an LLVM, if you're outputting a binary that runs LLVM bitcode. And the fact that the runtime generated code is slower includes, of course, that just-in-time compiler that's part of this image, right? So if everything else runs slower, that just-in-time compiler also runs slightly slower, and that means that these LLVM-based images are slower at compilation right now. However, we are working on all of these things and expect these will, like, if not entirely fixed, the gap will be much smaller in the future here. Now, when you write a Java application and you're using various libraries, you're not only using Java code. If you were only using Java code for everything, you're already good, you're golden. You can use native image and convert all this Java, you can have it analyze all that Java code, it will be converted into some native image, and you can run that. But to talk to the system, talk to the underlying platform, everywhere in some of these system libraries like JavaFX, there is going to be some native code that has to bind to the platform. And we partnered with the Gluon guys to create kind of Java wrappers around JavaFX and some of the libraries that you need to talk to the platforms to create Gluon Mobile, which is a kind of a set of libraries that you would need to write applications that can then be transformed via native image into binaries for other platforms like iOS, for Android, or for other store apps. And these additional libraries not only wrap the existing functionality that you would expect from kind of JavaFX libraries or whatever, they also, this work comes with the tools and the integration with Maven and Gradle to have your integration with your IDE, to have the entire process of writing your app, running it on the desktop, debugging it on the desktop, creating the native image, deploying it to the simulation targets on your desktop machine, deploying it to the real targets, the real mobile devices, all in like one nice little package. And there's also support for these additional features that some of these mobile platforms have, such as GPS sensors, orientation, and all these kind of things. Now, one of the problems that we had before was that Apple doesn't allow creating and running dynamic code on their mobile devices. So you can't actually run a just-in-time compiler. And here's where this split that we have between we can AOT compile things and we can just-in-time compile things and we can profile things comes in really handy. Because while if we're interpreting everything, it's going to be slow, but if we AOT compile and profile and then compile again with these profiles and can generate already optimized code, you're going to get very, very good performance even without just-in-time compiling on the platform. And there's additional advantages, obviously, because then you suddenly, because you're not allowed to just-in-time compile anyway on that platform, you can not ship that. And you also save the CPU time on that platform to do it, which is, especially on mobile, an interesting and important thing, because you want to be saving battery on these devices, right? So you don't actually want to run, you want to do most of the optimizations on your development platform as you're developing, and while you're creating the image, you want to be able to spend the extra time there rather than on all of your end users' devices and have all of them just in time compile all the time. So this is also an advantage really over just for example, cross-compiling something to JavaScript and then having it JITted on the platform. Because then you're just pushing all of that work to all of your users' devices, and you have them run hot and then waste their batteries millions of times over again. Yeah. So I already mentioned the tooling. So Maven, Gradle plugins are available to tie all of these things together. So you can, right now it supports Java and Scala compilation, and it ties together the compilation of the code with the native image generation, linking with all the libraries that are required, and signing for the store apps and all of these things, deploying it. And we support for these tools and for this setup, we support Java 11, 12, and 13 right now for iOS. Android, my last information was that it's basically working, but there is still, it's basically working for this app that I'm going to have a screencast on in a second, but there's some issues still that prevented us from actually handing it out to everyone right now, because they would just be reporting the same issues that we already know about. So I'm just going to show, I don't have an iOS device with me, so I'm just going to show a screencast of this iOS application that's by our friends at Gluon here. And it's just a chat app. You can find it at this GitHub URL if you're interested. It's really a small application, nice and easy to understand. And it basically when you download it and check it out, you can immediately use Gradle. You can just run it. It will build it and run it, and it will run on your platform, like on your desktop computer, and kind of give you a little bit of access to these kind of platform, like mobile platform specific things, like you can change the landscape and portrait mode. And this is just, the app isn't really interesting as such, but more as a like that this thing runs across these different platforms. So it's really just a chat app that connects to some server, pushes messages there, and then other apps that connect to the same server receive it. Now, if you downloaded this, if you checked out this this GitHub URL, you can use the same thing to run. You can use Gradle native run here to run it in the iOS simulator, in the iPhone simulator here. You first have to compile it. I skipped that in the video because compiling it actually takes a few minutes. So for this app, like on my machine, it was like a couple of minutes. So it's not too bad, but it's also not great because the Java compilation itself is much faster. But it's also something that will improve over time. But oh yeah, you just saw it basically just works the same on the iOS device. And if you have an actual iOS device plugged into your machine, you can also run it from using Gradle directly, push it to that device, and run it directly on that device. Just the same. So it's all nicely integrated with Gradle, and you can use your normal tools as you would expect. Develop on your platform and then deploy to any other platform. Now, why would you be using this over some existing solution like React Native? One of the advantages of using React Native right now is that because it's been around longer, it has a bigger community and thus more components are available at this point. One of the advantages of running with our solution, as I already alluded to, is that we don't run some JavaScript and plus native code, right? We don't have to warm up something on the user's device. We AOT compile everything, we profile guide the optimizations before, so you're running faster from the start. And also we have, as far as we think and know, we actually have better peak performance also than if you were doing the same thing on React Native. One thing that React Native has that we don't have right now is hot code updates, because we have this process of closed world and we analyze everything and then we create a binary that we push to the device. You can't actually easily push out new code to the device. That's something that we will kind of work around, but it's something to be aware of. We think, however, that if you can develop everything and it will run the same on your desktop machine and on these different mobile platforms, that just developing locally, debugging locally, kind of is already quite a good way to get some of these benefits that you would want with hot code updates. What we're hoping to achieve with releasing this and also pushing out Android support pretty soon now is that people are going to start using Java again and other JVM-based languages, and maybe also some of the dynamic languages that we support on top of GraalVM to build mobile cross-platform applications. The React and Flutter frameworks, for example, these are open source. So you could build wrappers for the JVM for those, and then just have those be part of your application. So when you build a native image, these things are linked in, and you push them out to the devices. Also, we could use kind of leverage these JVM language communities like around Scala and Kotlin to get people interested in writing mobile applications in whatever their favorite languages are, rather than forcing them onto these specific frameworks and platforms. And the next steps for us here in this context are we're working, as I said, we're working on improving the GC and pushing out the Android support. And for deployment to mobile, I said earlier that actually compiling the native image takes a little bit of time, and when you want to kind of iterate quickly and push things out to your mobile, you actually want to try it on the mobile device quickly and iterate quickly. That can be annoying. One of the workarounds that we're looking into is during development time, not actually creating the native image, but just pushing out a bytecode interpreter to the mobile device. So during development, you don't get the peak performance, but you get this quick turnaround time of just kind of, you can quickly try something. And then if you are working on optimizing and like tweaking the performance, then you build the native image and then you check it on your mobile device. As I said, if you're interested in this, please report problems you have, or even support us, contribute on GitHub. There have been quite large open source contributions already for the work on JavaFX, for the work on tooling. There have been contributions to this LLVM backend. So we are really very actively engaging with everyone in the community who's interested in this. And I would really just like to encourage everyone who's interested in this to join us in this community and on GitHub and talk to us about it and show off these things that you might be thinking about doing or that you're doing in this space. So we can really kind of start to spawn a community that says, oh yeah, we can again use JVM-based languages for true cross-platform mobile or niche products, hardware collaboration, development. So that's the end of the talk. So just, if you're not already using GraalVM, even if you're not interested in the cross-platform parts. Use it. Think of the planet. Save energy. But if you're interested in cross-platform development, here's another GitHub link from Gluon HQ to get started. There's some client samples in there. There's also people from Gluon here if you have specific questions about that. And just a quick reminder, you can try the Enterprise Edition and evaluate it for free. And if you decide to use it, you would get support from the actual development team, i.e. us. If you're interested in other GraalVM topics, I'm just going to leave that slide up here. This is tomorrow's set of talks that are related to GraalVM, talks and the Hacker Garden, where I'll be sitting tomorrow. So if you're interested in any of these aspects at different levels, come see us, come see these talks. And there's more talks on Thursday, but there's way too much to fit on the slide. Okay, thank you.
The native image, does that support Linux?
Yes.
Okay.
Yeah.
Just double checking. You mentioned a lot of iOS stuff.
No, it supports Linux, yes. Yeah. Thanks.
Do you have any plan to support API scripts?
Yes, yeah. There's already some work going on there. Some community members even contributed something on GitHub also for this, but I don't know the details, unfortunately. I really just know that somebody contributed something.
I already have a different application access to Stray
Uh-huh.
using the API.
Yeah, okay.
But I failed to compile it in native.
Oh, okay. Yeah.